Work with sound now. I know this all just seems pretty weird. I can't exactly hear the sound, but I think it's playing. Some free music archive song about rainbows that I just downloaded. Welcome. It's Friday afternoon. It is a beautiful day. If you are in the New York City area or anywhere where it's a beautiful day, you should turn this off immediately and go outside and enjoy the day. But if for some reason you're stuck, or maybe you're watching this outside in some magical way, can you hear me? First of all, is this working? Write in the chat. I don't know if anyone's there, but I'm here to continue my series, which is a tutorial series. Okay, hold on. Sorry, my brain is a little bit fried. It's late. It's Friday. It's the end of the week. It's very hot in this room because I've got these hot lights in here. But I'm going to keep moving forward. The music, it's a little bit weird. I'm going to fade it out now. It's distracting me. Okay, I'm going to check the chat here to see if things are going. You can hear me, great. There are 10 people watching already, that's amazing. Twitch is live. I'm live on Twitch. Supposedly 90 people are watching, which I find that hard to believe, but okay. So anyway, welcome. Let me set the stage here for a little bit of what's gonna happen this afternoon. It is about 3:30 p.m. New York City time. My name is Dan, and I stream live on YouTube and sometimes on Twitch, and I make videos about creative coding and a variety of related topics. This morning I was here, if some of you are here, I did a couple challenges where I tried to program Space Invaders, and I tried to program this like mitosis simulation of a cell splitting, both in JavaScript. But what I want to do now is continue a series that I've been making. And I'm going to pull this up here behind me so you can have a look at this. This is my kind of outline. I want to continue my series, which is about Git and GitHub. Now, today, if you don't know, is poem in a pocket. Oh no, yesterday. Yesterday was poem in your pocket day. I have a poem in my pocket. I'm going to read it to you. Clouds by Christina Rossetti. White sheep on a blue hill. When the wind stops, you all stand still. When the wind blows, you walk all away slow. Boy, I really screwed this up. White sheep, where do you go? It's good to start the day with a poem. I actually don't have a poem on this piece of paper. It's on the computer screen here, but it was poem in your pocket day, and I forgot to print it out. I was going to put it in my pocket. I had this whole plan. It didn't happen. What I'm doing here with this tutorial series, in case you didn't, besides making a fool of myself, is attempting to teach concepts around version control, Git and GitHub, without worrying about programming and source code and all of that stuff. Now, this brings up a sort of a related question that I discovered. There was some discussion on Twitter about whether or not Git/GitHub is a good tool for authors. So let's say you're writing a novel, or you're writing a programming textbook, or perhaps you're writing a poem. Does it make sense to use Git/GitHub when you could just use Google Docs or Dropbox or any number of other tools that keep track of versions and allow you to do all sorts of collaborative features? So, I think this is a very interesting discussion. For me, using Git and GitHub has been incredibly useful for writing technical material. But I can see how if you're really an author writing an essay that, it's a lot of extra stuff that you don't need. However, I do think it's useful to learn about Git and GitHub without having to worry about code and all of the stuff that's wrapped up in a software project. This is primarily the reason why I'm using the sort of lens of poetry as the content existing in a GitHub repository. Now, I also think that perhaps the creative world is ripe for experiments with Git and GitHub. So what would it mean to use all of these concepts like branching and forking and pushing and pulling and commits and trees to create some sort of collaborative creative writing experiment? So I encourage anyone watching these videos who is not a programmer or who is a programmer to go in that direction. To that end, the first tutorial that I want to do today is teach about what it means to fork a repository and what it means to do a pull request. And to that end, all of you watching here, I would like you to follow along and make a pull request on my rainbow poem. And we are going to make together on this Friday a collaborative rainbow poem using Git and GitHub. Are you with me? I don't hear anything, but I'm going to look at the chat. Maybe somebody's saying something. Okay. Oh, Earth Day. Nobody heard the music. That's fine. I'm checking here, reconnecting. Today is Earth Day. I forgot about Earth Day. So you should really go outside and not watch these programming GitHub tutorials since it's Earth Day. And I'm open to suggestions, but I think maybe what we'll do is we'll think about this rainbow poem as a celebration also of Earth Day. GitHub, forking and pull request, rainbow celebration of Earth Day. How about that? Oh, I have something else. I have another topic before I get started with the tutorial. Wow, only Friday afternoon. It's good. I think people are off doing fun. I had so many people this morning, and people are slow to trickle in. But okay, so I have another topic I wanted to ask about, which is that I've been thinking about trying to create a community space, maybe for people who want to discuss or ask questions about the videos or suggest videos. You know, I'm really walking. At some point I might start a Patreon, but I don't know if I want to do that yet, but maybe I do. But anyway, so someone suggested creating a Slack channel. I was also thinking of making a Facebook group. If anyone is interested in that or has ideas around that, what might be a good way to discuss topics for the next live session or suggestions and that sort of thing. I'm looking to create more community spaces for us all to interact together. So stay tuned for more on that and write your comments in the chat. People are saying yes, but I have no idea what you're referring to because you are about 20 seconds behind me, although I suppose maybe you're thinking about the Slack channel. If somebody wants to go ahead and create a Coding Rainbow Slack channel, if that's what you're saying yes to, please go ahead and feel free to do that. And I honestly, I should do some tutorials on Slack and maybe writing Slack bots. I think that's a thing, but I'm an old person, I guess. I don't know what Slack is exactly, so I'm going to get used to using it because I hear it's a thing. Oh, Patreon. You're all saying yes to the Patreon thing. Okay, maybe I'll do. I don't know. The thing about the Patreon thing is, first of all, it would be great for this to be something that generates income for me. And I have YouTube ads on some of my videos, and kind of just a little bit, tiny bit, little like drop in the bucket type thing. I worry about doing the Patreon thing and suddenly it becoming this like burden. I'm really just doing, mostly I just enjoy doing this so much I'm hesitate to do anything. But I'm gonna think about that. Okay. So here we go. So I've got to get myself organized. I'm going to get myself organized here. I need to come over here. Let me know how this whiteboard looks. I'm going to clean it to write some things out. Okay, so what the first two Git and GitHub tutorials that I made, one was about just sort of like the basics and what everything is and how everything works and what a commit is and what version control is and how you look at a project's history. And another tutorial, the second tutorial that I made, was about branches and what a branch is in Git and how you use GitHub to create different branches as well as to merge branches. By the way, I'm vamping here by just like talking while I do this. So what I want to do here is make a kind of recreate what was on the whiteboard a little bit at the end of the last video to pick up and look at pull requests. The other thing that I need to do, is in order to simulate pull requests, I'm going to want to create a second GitHub account, which will be the one that will do the pull requests, I think. So I'm getting situated here while people are trickling in and joining live up to, let's see here. So if I recall, let me get myself organized. I was on GitHub at one time. Okay, I'm logged in as this user named Rainbow Coder. And now what I need to do, look, people are already, oh no, that was 3 days ago. And what I have here in my repositories is Rainbow Poem with this particular. So this is where I last left off. And what I'm going to show in this video is talk about what it means to contribute to somebody else's GitHub repository, to propose a change. And the concept will be forking and pull request. But in order to do this right now, if I were to click the edit button over here, I'm the owner of this repository, so it's not going to automatically be like a fork and all of that. So what's the best way? Oh, you know what I can do? I'm just going to sign in as myself in a different, I'm going to open an incognito window. And then I'm going to go to github.com, and I will log in as Schiffman. So this is my regular old-fashioned GitHub account. And this looks good. And then I'm going to go here, and this is what this particular repository will look like from my vantage point. And I'm going to cover forking and that sort of stuff. OK, good. I'm looking in the questions. Hello, Mohammed from Bangladesh. Wow, this is amazing. See, this is one of the, I tell you, this is one of the reasons why I just love doing this to, like, you know, I would love to meet in person, but to have these interactions and hear from people from all different parts of the world who are learning about programming and processing, and it's great to be in touch and here. That's super exciting to see you online, Mohammed. Okay, okay, so let's see. Now, what have I covered? What have I covered so far? I covered the concepts of version control. We talked about what a commit is and what a branch is. Oh, okay. I kind of want this to be in the order that I was thinking. I talked about what a repository is, what a commit is. We had this idea of a commit hash. What a branch is and what it means to merge a branch. So now, in this particular video, if I come back over here, forking and pull requests. That's it. How to fork a repository and make a pull request. By the way, just so you know, in case you're wondering, the way that I'm doing this tutorial series is I'm doing everything on GitHub, on the website, using the GitHub interface. And as I get further along, actually, probably here in video number 5, I'm going to look at actually cloning the repository to your computer and doing all this stuff locally, magic with terminal. But I wanted to try to make a tutorial series that didn't start with terminal. Not sure if that's a good idea, but that was my idea. Okay. People are suggesting a subreddit. That sounds like a reasonable idea too, as a way for this community of ours, whatever that may be, to be in touch with each other. Okay, so I think I'm mentally ready for this now. I have this here, and I'm going to... so what I have to remember is I've got a GitHub repository. I'm a GitHub user with a repository with a text file in it. I am thinking about the fact that it's Earth Day. And so this poem could have something about that in it. And I'm thinking about what it is that I'm adding to here in terms of forking and pull request. Any questions, any thoughts, any comments before I start this first video? I will check the chat. And by the way, this morning I forgot to hit record. So the stream, it gets archived on YouTube no matter what, but I keep a separate recording of all these videos, a higher resolution, higher quality one, and then I edit things together to get put online. I don't do that. Somebody is helping me. Never mind. I was like going to say your name, and then I forgot if I might pronounce it incorrectly. Mathieu from Canada. Anyway, anything but a Facebook group. Yeah, you're probably right. Okay, so what I was saying is another thing you guys can all remind me of always is how are your batteries doing for the microphone? I got 2 bars here, should be pretty good. And did you hit record? So I need to remember always to hit record. Okay, I think I'm ready to begin. And then I stand here and I look here. I think this works. I think we're good. Have a little sip of water. Okay. And yeah, I think I'm good. Okay. Fork pull requests. I have my trusty marker here, and here we go. Friday, 3:45. What's better on a Friday afternoon than thinking about pull requests, GitHub, and rainbows? Oh, I don't have to hit record anymore. Okay, yeah, yes, I hit record, thank you. So I'm recording the whole thing. So I'm just going to start. There will be a time when I start. Welcome to part 3 of my GitHub for Poets tutorial series. In this tutorial, I'm going to show you, the viewer, I got to start over, as I felt weird. Okay, one more time. Okay. Okay, I have to close. The other thing I have to do is I have to, I have a laptop where the chat and a view of myself is on, and I have to close that lid a little bit. Otherwise, it distracts me. Okay. Hello, welcome. Part 3 of my GitHub for Poets tutorial series. And in this video, this is, if anything, this might be the most important one for you to watch, or the most exciting, or perhaps, hopefully, maybe, if I can make it so, the most interesting one to watch. So what I have here is a poem. It is in a GitHub repository. I created an account called Rainbow Coder, and what I'm going to show you in this video is how you, as someone who is not me, could contribute to my repository. Now, this usually happens in the case of source code because you want to fix a bug or suggest a change, but we're going to sort of not look at source code to make things a little simpler. So you might think of another line you want to add to this poem, that sort of thing. So how do you do that? So there's 2 concepts first that I want to add to our list of Git concepts before I start typing stuff in here in the browser. I'm going to come over here. These are all the concepts I've covered so far in the previous 2 videos, and I'm going to add 2 things to our list here. I'm going to add fork, and I'm going to add pull request. So these are the 2 new concepts that I'm covering in this video. Now, what does it mean to fork a repository? So let's say this little circle here with the word repo in it represents a particular repository. And you've been making changes along that repository. I had a diagram like this, a bunch of different commits. And then also perhaps you had some branches where you tried some other things out and you merged those branches in, that sort of thing. This repository is sitting on GitHub in my account, Rainbow Coder. What if you love this repository so much, you want to take an entire duplicate instance of it and have it live in your account so you could work on it separately with the same stuff, but not be mucking around with not have to have privileges or permissions to make changes here, but also not by accident mess something up if you weren't sure about what you were doing just yet. This is what it means to fork a repository. Forking a repository is essentially like, I was almost going to use the word clone, but I don't want to use the word clone because that's a specific GitHub term that I'm going to add to this list for later. But it's like taking an entire other instance of the repo and just having it under your account. So I have another GitHub account, which is my main one called Schiffman. And what I'm going to do is I'm going to pretend to be both Rainbow Coder and Schiffman. I guess I don't have to pretend to be Schiffman because that's who I am. Maybe, anyway, this is all getting a little strange. But so I'm going to fork it, and then I will have in my account, my GitHub account, an exact replica, I didn't get this right, of this entire repository and its whole history. So that if I decide to do some stuff, I can make as many branches and do various things as I want without affecting the original core version. That's forking. Now, that's what it means to fork. Now, what does pull request mean? Pull request means, let's say this particular branch that I've been working on, I just love it. I have come up with the most elegant, poignant, meaningful set of verse ever. And I want to contribute it back to the original repository. That would be a pull request. Now, what am I doing? I'm essentially sending this code to this repository as a pull request. And it's up to Rainbow Coder to accept or reject that pull request. The reason why it's called a pull request in GitHub, it's so strange, but let's say if I want to send something this direction, that's going to be a push. If I want to get something the other direction, pull, that's going to be a pull. So sending out is pushing, coming in is pulling. So really, I, as Shiftman, want to push my stuff over here, but I can't because I don't have permission here. So I'm saying, would you please, Rainbow Coder, pull my changes? That's a pull request. Okay? So these are the concepts. Let's go and actually do it here. And if you're watching this live or if you're watching the archived version of this video, please make a pull request. We're going to invent the world's greatest collaborative poem about rainbows. And since today's Earth Day, I don't know what it'll be when you're watching this. Maybe add some stuff about the Earth in there too. Okay, back over here. Now, here it is. So I am logged in here as Rainbow Coder. And what I've done already in a separate browser, in a separate browser window, is I am at this exact URL of this particular repository, but I am logged in as Shiftman. And you can see here, my little smiling icon is up there, and I am looking at the Rainbow Coder Rainbow Coder's account and the Rainbow Poem repository. So the truth of the matter is, all of this stuff, I could fork and then make a pull request and do all of that. There's actually a really quick and simple way to do this because GitHub will kind of take care of everything for you. And I'm going to show you that first. Because you could say, we could go to the poem and you could see, look, there's the edit button. And look what it says. Fork this project and edit the file. So GitHub already knows that you don't have permission to edit the file directly. So it assumes if you're trying to edit it that you're going to that you want to fork the entire project. So if I actually just click edit, it's going to automatically create that fork for me. Another way I could create the fork is to click this button up here. Oh, you can't really see that. This button up here in the top right corner, fork. So I don't know which one I want to do right now. Flip a coin, spin a wheel. Let's start with the let's fork it. Let's do the fork. Come on, let's be bold today. Okay, so I'm going to click this fork button right now. Here it goes. Oh, whoa, look at this. So one thing you'll notice, by the way, that I, as a GitHub user, belong to a bunch of different organizations, and that organizations have different accounts. Interesting to note this. If you just signed up, probably won't have this happen to you, but I'm going to fork it to my Shiftman account. You can see it's forking it. It should only take a few seconds. Come on, GitHub, do the fork dance. Okay, it finished. I don't have to dance anymore. So now you can see, look at this. I now have an entire duplicate version of this repository under my account, and it even says where I forked it from. This all makes sense, right? So now what I want to do is go back to Poem, and you can see I'm working in it, and I can just hit edit now. So I can edit this, and let's Earth. By the way, everybody, when you're doing your forks and pull requests, please get rid of my original poem. Nothing about it was any good. Earth Day is a day. Oh, wait, okay, let's just say, I don't know, recycle. Recycle is a good, okay, so I panicked. I don't know what to put about Earth Day. But, so I'm adding a line, recycle, and then I'm going to now go down here and look at this. So I can commit directly to the master branch. Now, note, because I'm working in a fork, I am committing to this master branch in my forked version of the repo, not the Rainbow Coder one. But sometimes it's kind of good practice if I'm ultimately going to propose a change to somebody else with a pull request to maybe create a new branch. So let's do that, and let's call this branch Shiftman Recycle. And I'm going to say adding recycle. Recycle. So, I'm doing a terrible disservice to the world by not putting in excellent, thoughtful commit comments, but you should be more thoughtful about that. And then I'm just going to do propose file change. Now, interestingly enough, oh, whoa, this is so, I did this in an overly complicated way by making the separate branch, but it's fine because what I'm doing here is, what it wants me to do is automatically, I got to restart this video. It's fine. Let's keep going. This is so crazy, but it's fine. This is normal, and we should run into these types of things and figure them out. So because I created a separate branch, GitHub is sort of automatically detecting that maybe I want to propose to merge it back in here. And and then from there I might do a pull request. Let's actually, let me go backwards, and I'm not going to do this extra step of the extra branch. I'm just going to edit master directly and then do a pull request from there, which might be a little bit simpler. And somebody on the internet is probably going to yell at me that I'm doing things incorrectly, and then I'll make another video to correct that. Okay, so actually, no. But what I'm actually going to do, even though I said something different, is click Merge Pull Request and confirm merge. And so now you can see now you can see my particular version of the repository. I was doing so well. Now has the recycle in it. So what I just did there was this extra step of making that extra branch was rather unnecessary because I could have just edited master directly because I'm only working within my version of the repository. Let me get to the important point now. Hopefully I didn't waste too much of your time. What happens now if I go to here? Now look at this. There is an option right here now I'm in Schiffman/Rainbow Poem. I can say new pull request. And what that's going to do is say to when I click new pull request, it's going to tell the original repository, Rainbow Coder, that I have now a pull request. So I'm going to create a pull request with this commit, adding recycle. I'm going to create that pull request. I'm going to say, hey, I added recycle. Please, this I am really thinking about the earth and how much I love rainbows today. Okay, so I'm going to create this pull request, and now there's nothing left for me to do. I just sit and wait. I wait with bated breath and anticipation, hoping that my pull request gets accepted. And yet, even if your pull request does not get accepted, you have done a good thing on the internet today by learning about and submitting a pull request. Not all pull requests get accepted, but just the act of doing one is a positive thing to do in the world. Anyway, so now I can go to the window. I can go back now as the Rainbow Coder. I can go back to this original repository, and I can select now. Now, this is if somebody, now pretend you're someone gives you a pull request. I can go here to pull requests, and I can see that somebody actually added another pull request here already. I'm going to merge that one in perhaps a little bit later. I'm going to look at this one. I can see like, what was changed? This is the thing that was changed. I can look at it and say, blue, green, indigo, recycle, unicorn, yellow. Maybe I would have put recycle after unicorn, but pretty good. So I'm going to, because this video now has probably gotten way too long, I'm going to go back to here, and first I'm going to write, thank you so much. I love this change. And I'm going to hit commit, and then I'm going to right here, and I'm going to do it. I'm going to do merge pull request, and we have now started, even though it's just me doing the pull request, the world's first, this might not be true, but the world's first collaborative GitHub poem about rainbows on Poem in Your Pocket Day, or the day after Poem in Your Pocket Day. Okay, so this is the end of part 3. I encourage you to go online, try to make a pull request to my repository. A link to the repository will be in the video's description. You find another repository if you know about code, fix somebody's bug in somebody else's repository, add something, go and make a pull request on the internet, on GitHub today, and see how that goes. And in part 4, I'm going to do something more with Git and GitHub. Look for part 4. I forgot what it is, but I'm going to keep going with this stuff. Okay, see you soon. Goodbye. Okay, live chat people. Okay, is this still working? Was that okay? Did my audio cut out? Did that make sense? How long was that, by the way? Is anybody paying enough attention to know? I kind of got lost. I wish I hadn't done that extra step of trying to branch. The idea of a branch versus a fork is very confusing, and I feel like I need to make another clarification video. I'm going to do that right now. I don't know if I fully understand it myself. Yeah, because what happened? Let's actually look now. One thing I want to check now. Oh, I should have shown this. Is I could just do this at the beginning of the next video. Yeah, so I guess the issue is it doesn't show up as a separate branch because it was done in master. Okay. Yeah. We'll see how this goes. I feel like I did a good explanation of what a fork and a pull request is, and then I got a little bit muddy in there in the actual doing it. Okay, so let me look at my GitHub issues. So if you guys are watching, please make a pull request. Oh, here's one. Oh, this is so good. I can't believe I didn't think of this. We got a nice little addition about Prince. Let's. I love this. Let me thank you, Dries der Rook. Merge pull request. Okay. Great. And now wait, hold on. This pull request I probably has conflicts now. So this is good. We're going to resolve these. I'm going to leave this in here someday. So I screwed up by not merging this one earlier. Sorry to B8 Horpet. This pull request will live forever until I deal with the conflicts in a separate video. Let me just check Twitch here, see if anybody has questions there. Somebody writes, is this the weird side of Twitch or site of Twitch? Yeah, I guess it is. It's definitely the weird side of something. Okay, how are we doing here? I wonder how long. This is the one issue with me not recording these videos. I should get a timer. Maybe I'm going to get a timer for myself. Hold on, I'll be right back. Okay, so sorry, I'm going to use my phone as a timer so I have a sense of how long these videos are that I'm making. Okay, all right. Let's see if we got any more pull requests. Come on, internet. Okay, would a translation of the poem be a fork or a branch? Interesting question. So let's think about this. What I might suggest for a translation of the poem would simply be an addition. So I would make a fork, and then in that fork, I would make a new file with the poem translated, and then I would do a pull request to add that file to the original repository. So you could have a fork with it just translated, but then your fork is so, I think it would make more sense to just either start a new repository from scratch, and this project is a translation of this other project, or to, what I think would be better to just have the English version and another language version in a separate file, and you can keep working on that file in your fork and then send that file back to the original repository. That's what would make sense to me. Just to think about something kind of code-wise, like I have this Nature of Code examples repository, which is all of the code examples from my book, Nature of Code. And then I also have the Nature of Code P5JS repository, which just has no relationship between the two, but it's a duplicate. They're just two separate repositories, because if I'm making a change in one, I have to go, it can't really be aligned with the other. I have to do that manually. So, but what I do in the main repository, I just said do. What I do in the main repository is I keep a README file which keeps links to all sorts of other forks and related versions. So those are like translations from one programming language to another. Okay, I'm looking at the chat here. I am seeing if there are any more pull requests. No more pull requests. So hopefully this video is going to go out on the internet and everyone's going to give me pull requests. Okay, so let me think here. I'm going to show you how to do a GitHub issue, and then how to have a commit relate to a particular issue. That seems reasonable, right? Okay. And then I think I might just answer some questions and kind of be done for today. Or maybe I'll do like a quick coding challenge or something. And maybe I'll save this, like all the cloning stuff, for another day. Something like that. Now that it's warm outside, this room gets very hot, so I'm going to have to think about that. But okay, so let's see here. Let me get myself situated. Oh, I got some new pull requests. Let's take a look at it. This seems reasonable. So let me accept this. Thanks for the change and merge pull requests. There we go. Okay, there we go. All right, now. Okay, here we go. I'm going to get ready and do video tutorial part, GitHub tutorial part 4, GitHub issues and closing issues with commits. Okay. So I'm going to use this timer so I can have a reference to how long this video is. So I will hit, and is the microphone okay here? Let me fix that a little bit. And I think I should be good. Okay. Interestingly enough, no, it's okay. Okay. And I'm in the right account. And yeah, okay, sorry, I'm spacing out. Okay, here we go. Issues and commits that relate to fix issues. Okay. Part 4 of this Git/GitHub for Poets tutorial, I'm going to talk about GitHub issues, how to file an issue, and then also how to refer to that particular issue as you are working on particular commits. Now, what are GitHub issues for? Now, this is one of the few things that I'm showing you that's actually not necessarily a Git concept. This is purely something that exists as a layer on the GitHub website. So at some point, when you take your repository and put it locally onto your laptop, which I'll show you, I think, in the next video, those issues won't come. The issues just are for the purpose of collaborating through the GitHub website itself. But they do play a vital role, and I find them incredibly useful in managing complex software collaborative GitHub project thingy-mabobs. Okay, so any repository, here I have the Rainbow Poem repository. You never know when a pull request is going to come in while I'm making this video. And by the way, I hit refresh and hope I see a pull request. No, okay, whatever. There's one, that's an old one. I'm off the track here. Okay, so let's look here. There is a button here, a link here, up here called Issues. Issues is a place to leave a comment about a project. You know, this can be a variety of things. It can be, I found a bug. When I press this button on this app, the whole thing crashes. Or it can be, you know, I noticed that this word was misspelled. Or this, it can also, you can use issues to have feature requests or to ask questions. In general, GitHub issues are not really meant for the types of things you might find on a programming help forum. They're more specific questions and issues and bugs and feature topic discussions around a particular project. That said, all projects and GitHub repositories probably treat and use issues in different ways. You can use labels, you can organize them, so many possibilities. What I will say to you is that, in particular, if you're watching these videos and you're interested in processing or P5.js, it sometimes can feel very scary and intimidating. Like, I'm going to file, I found what I think is a bug, but I'm going to file an issue, I'm going to write something, and then everyone's going to come in and yell at me and tell me I did it wrong. And I will say to you that this is not the way the world should work, or GitHub or Git should work, or in particular, please, if you're not sure, file the issue anyway in processing or P5.js projects. Write at Schiffman in your description to say that and say that I said you should. Don't worry, there's no way you can do it wrong. The point of the community is to be open and welcoming and to help everybody figure out how to do all this stuff. Nobody really knows how to do it anyway. The people who say that they do probably don't really. I definitely don't. So anyway, so please, I'm also just making this video to encourage you to file GitHub issues and participate in the open source community. Now, let's say I go over here and click on issues. There aren't any issues because there aren't any, but I'm going to write a new issue. So I click here and write a new issue. Issue should get a title like today is Earth Day. Today is Earth Day, And I think the poem should reflect that. Now, another thing you could do, which is really useful, this is a little bit of an aside, but let's say you're trying to reference something that's visual. You can quickly take a screenshot of something. I just took a screenshot, and I can actually just write down here that screenshot should be right here on the desktop. You can see that image file. I can drag that screenshot right into here, and it's going to upload it to the issue. I can go here under preview, and I can see this is what my issue looks like now. It has an image in it. And also, the other thing that I should point out is this whole, this entire issue thread, you can use something called Markdown, which is a special kind of markup for writing things. For example, this is a link. So this is the syntax for having a link to something you can see. And I said, and this is bold, I think, or maybe that's italic. That's bold. So there's a lot of markup that you can learn, and if you want to learn about that, you can, somewhere on here, there's a styling Markdown with Markdown is supported, and if I click on that, it's taking me to a whole page which gives me all the stuff about Markdown. But that's a little bit of an aside. So you can see now I am writing my issue, and I'm going to now click submit. Now, I could add labels, like I could say it's a bug, a help wanted. There's sort of standard labels. I could create my own labels. I could add it to a milestone. I could assign it to somebody saying, like, this is the thing you should work on. I'm going to assign it to myself, Rainbow Coder. And then I'm going to now submit this issue. And you can see now the issue is submitted. And if I click back on issues, here is a list of all the issues. Now notice a very important thing here. I have 1 open issue and 0 closed issue. An issue is open until it is resolved. When it is resolved, it is closed. Only the person who submitted the issue or the owner of the repository can close an issue. So you should know, by the way, that what I'm doing, even though I'm the owner of this repository and I'm submitting the issue to this repository, I have a timer going to figure out how long these videos are, and I never hit start on the timer. I'll hit start now. I've probably been talking for about 5 minutes. So I was saying a second ago that I am the owner of this repository and I'm submitting issues, but you, as somebody else, could come, you can submit issues to any repository. Now, let's say I want to resolve this issue. So pretending it wasn't me who submitted it, or it doesn't matter, even if it was me who submitted it, I now want to make a change in my poem to acknowledge this particular issue, and I want to refer back to that issue. So let's do that. I'm going to go to, I'm actually going to just open a new tab so I can come back to that tab. And I'm going to go here, I'm going to go back to the poem, and I'm going to click Edit, and I'm going to zoom in here, and I'm going to write at the top, today is Earth Day. That probably has capitals, Earth Day. It's like a holiday day special thing. So I'm going to write today is Earth Day, and I'm going to say adding Earth Day as per. Now, how do I refer to a particular issue? All issues have an ID number, and I'm going to go back to this tab and see what is this issue's ID number. It's actually number 10, which is surprising to me. I would have thought it would have started with number 1, but that's fine, and we can be sure about that by if I click on that link, you can see up here in the URL, it's issues/10, that's important too. So I can actually just say in my change, as per number 10. So I am now making a commit relevant to that particular issue. I'm going to now click commit. And if I go back to this issue page and hit refresh, you can see here the camera's about to go off. It took a second for it to appear. You can see that this page now automatically has a little entry that said that Rainbow Coder added a commit that referenced this issue just now. This is very useful because if someday later I want to revisit this discussion about this particular issue, I could now click directly on this, and I could see, oh, this was the change, and I can look directly at that particular change associated with that issue. Now, if I felt that that was done, I could click this close issue, and then the issue would be closed and would go into the closed category. However, I can do something else. There are certain key words that will automatically close an issue with a particular commit. So for example, if I go back to the poem and I hit edit again, today is Earth Day, I love Earth Day. As the second line of the poem, I'm adding I love Earth Day. I can say, this fixes number 10, adding that I love Earth Day. So now if I use the word fixes inside my particular commit message, it's going to recognize that. Whoa, I don't want to stop the broadcast. It's going to recognize that as a commit that fixes. Oh, I messed the camera up a little bit. It's fine. Everything's okay. It's going to recognize that. Sorry. It's going to recognize that as a commit that resolves that issue and closes it automatically. So let's see if that happens. I'm going to say commit. And now, if I go back to this particular issue and hit refresh, look, it's already closed. So you can see Rainbow Coder closed this in 45355F5. What's that? Remember, oops, every single, here I am, every single commit on the tree of your Git repository changes thingamabob. This light is casting a terrible shadow. It's not supposed to do that. Every single commit has a particular unique identifier known as a hash code with it, and that's what you're seeing here. So incidentally, you can also reference commits in an issue. So sorry. So I'm going to go back. I know this is a little bit of a frantic video. I'm going to try to think more about rainbows in the earth and be a little more calm. But I'm going to go to my history here, and I'm going to see, first of all, we can see, look at all these people contributing to this repository. Please file your pull requests. And I'm going to go, and I'm going to look this particular issue, this particular commit. I'm going to click on it. And what I'm going to do is I'm going to grab in the URL this full hash code. I'm going to do Command C. So I now have copied that. And I am going to create an issue that says, I'm not so sure about this change. I propose that we consider doing something slightly different. Though I do love the thinking. I don't know, right? And then if I paste that value in here, see how I paste that hash code into the text of this particular issue, and then I hit submit? You can see how that resolves itself automatically to a link that goes directly to that particular change. Today is Earth Day. So there's lots of things you can do on GitHub by referencing issue numbers and referencing commit hash codes in your commit messages or in your issue descriptions. So here's what I would like you to do. I would like you to do a couple things. If you're watching this video, one, file an issue on my Rainbow poem repository. Say something about what you think the poem should have. Then I would suggest that you make a pull request that references that issue, that resolves it. See if you can do that. I'm going to accept all of your issues and pull requests and close them all, and it'll be exciting to see how that works for you. And once you've done that, you're well on your way to contributing to other open source GitHub repositories. Okay, great. So this wraps up this part 4, I think I was in part 4, about Git and GitHub. Thanks very much for watching. Okay. So how was that, everyone? Did that make sense? Was that useful? Is there anybody watching? There are some people watching. I got to go check all these pull requests. I'm going to... okay, hold on. Let me... I'm just fixing that camera thing. Okay, sorry, I'm like reading Twitter. There's another conversation going on. Let's look at all these pull requests and see if I can... let's see if I can accept them. So I'm a little worried that we're going to get merge conflicts, but that's okay. I didn't even look at that one. Let's see what this one, blue is cold. I want to make sure that no one's putting any offensive material. Oops, this has merge conflicts. I'm going to resolve these merge conflicts later. Maybe I'll, a simple French translation. Oh, look, and it's a new, this is the greatest thing that's ever happened in my entire life. I'm going to read this to you with my terrible French accent because I just have to. Because yesterday was Poem in a Pocket Day and today is Earth Day, and I should get to read poetry in French on this live stream if I want to. So what you realize just happened is somebody on the internet took our poem, translated it into French, made a separate file, and now has a pull request. So I don't really speak French, but I'm going to read this anyway. l'arc-en-ciel, la licorne et le pony. Violette, rose, orange, bleu, vert, indigo, licorne, jaune, rouge. Voici les couleurs de l'arc-en-ciel. So that's how you say rainbow, I guess. Et la licorne, which is unicorn. Pony! Okay, great. Thanks for indulging me in that. Somebody can, I don't know, use that for whatever you want. So let's definitely merge this. Okay, hold on. Merge. I'm just too excited about this. Merge pull request. Merci beaucoup. Did I spell that correctly, French folks watching? How'd I do? Comment and merge, confirm merge. And so now you can see here that there is now two files. There is a second file. Remember, it's very important to realize that a GitHub repository is not just one file. It's a lot of files. They all can be edited and worked on in different branches. Let me check the chat, see if anybody has any questions. Okay. All right. So I don't know. I think that I'm a little bit. I think that I might have reached my limit in terms of Git and GitHub today, and I might continue that next week. Obviously, the cloning and all the doing the stuff local is quite important. It's 4:20, no pun intended or whatever. I'm just drinking water. And I do have a little bit more time, but not a huge amount of time. So maybe I'll do another, dare I do another coding challenge, which I always say is going to be, because that only have like 15 minutes, and then that ends up taking an hour. But if you have any questions or suggestions for questions about Git and GitHub, please ask them. And then also, if you have questions, any suggestions for a coding challenge, let me know. So let's see if I can do a coding challenge. Let me go back to my list. I'm totally not paying attention at all to this timer thing. Oh well. Fork pull request. So I've done 4 videos so far. That's exciting. Okay. And how are we doing in pull requests? We've got 2 now. Okay, sorry, I lost my train of thought. I'm going to close these out and go to 10-minute challenges and see what we've got here. We have got, I did this morning. So here's a bunch. Oh, yeah, these 2 I want to think about. I'm not ready. Oh, I said I was going to look into sound and get that ready for this afternoon. I got back here to the school for poetic computation space, and I just immediately came here and turned stuff on. So, 10-minute Pong in P5, Lorenzo tractor. Ooh boy. One thing I was thinking about doing if I summoned the courage to do a Patreon is that I guess one of the things that I could have is for people who contribute to the Patreon, you get to like submit a particular challenge or a question that gets solved in a video. So one thing I don't want to do is do like private videos. But I could give like benefits where like you get to propose a topic and have that answered. Morph with lerp. Okay. So maybe I will. Let's see. What do I feel like? I just kind of don't want to do Pong because both of the last 2 challenges I did, one was the Snake Game and one was Space Invaders, so I'm a little tired of that. These I would do. A character with eyes that follows the cursor I would do. I have no idea what a bird generator is. Maybe we should, maybe these are good. I like the idea of like Pong having to happen really quickly. I guess I could include Pong. I'm leaving it to chance. Somebody in the chat asked for Pong. Oh, solar system generator. I like that. Okay, so here are 5 options. Okay, and let's see if there's any more. Rain is a good safe one. Yeah, rain seems so, but I shouldn't poo-poo rain. It's Earth Day. Simulating rain. Purple rain. Oh, that would be nice. Purple rain. I should do that no matter what today. I would love to like play like some Prince music or something, but I think I would violate some sort of copyright something or other. Okay, so here we go. I think this is a good list. Whoops. Do I not have Chrome open somewhere? Here we go. I'm going to make a plea again for anyone who feels so inclined that this particular randomizer project, there's a GitHub repository under my account called Randomizer. It's a quick little project that I've been trying to do things to put a class into random groups or to pick somebody to present a project, but it needs like some design work, some interaction, visual design work. Anybody's interested in helping, please contribute to this with a pull request. But right now I'm just going to paste these topics in. I'm going to see if anyone, and I'm going to go to spin. So now, why? It's so interesting. If I make this, the font suddenly is so, oh, I know what I did before. I must have zoomed in on it. So let me make this smaller. Hit refresh. There we go. And sorry, I'm going to bring this down a little bit. And here we go. So this now is, oops, let me do this again. Ew. A little bit more. I guess what I'm saying is this needs some design work because it's not doing what I want it to do. That's fine. Let me do this. OK. That's fine. OK, so we're going to run this. We have Pong, eyes following the cursor. We have Pong, solar system generator. Ooh, what's happening here? OK, it's working. Eyes following the cursor, shape morphing with lerp, springy rope thing, simulate purple rain, solar system generator, Pong. OK? I did already do morph with lerp, but I never released that as a video because I got so off track in that. I thought maybe I would do it again, but it would be a little disappointing maybe to do that again today. Let's just hope it doesn't land on that. And also I thought I would do it in JavaScript, but yeah, I did do it already, so that code does exist out there. Okay, let's spin this wheel. Okay, I'm kind of rooting for Purple Rain now, for fate. Okay, come on, spin that wheel. Oh my, Pong. Oh my God, it always just wants to do games. Go, solar system generator. Haha, all right. Solar system generator. Okay, I don't know what that is exactly. Oh, we could do 3D. Let's do something. Let's do this twice. Once in JavaScript, in 2D, and then I'll open up processing and do a 3D one. How about that? That sounds good. Okay, so we got solar system generator. I feel like I got to do the Purple Rain thing though, right? How much time do I have? It's 4:25. We'll see how much energy I have. Okay. Hello everybody watching. I'm just sort of checking chats. Rigged. Yes, definitely rigged. Okay. Okay, sorry, let me minimize that. And I guess I could do the whole solar system generator in processing, and that way I could just move to 3D more easily. Maybe I'll do that. I feel like I've done the last couple in P5, so maybe I'll do this one in processing. And I'll make a P5 version of it, but yeah, everybody wants 3D and P5. To me, I don't know. We'll try it. We'll try both. Yeah, I'll try it. But what I would rather do is work it out in processing because I know that how all the 3D stuff works really well in processing, and then I'll translate it to P5 and see what works and what doesn't work, and we'll file some GitHub issues if stuff doesn't work. Okay? Yeah, we're going to do Purple Rain today, everybody. I mean, how can we not do Purple Rain? I got to do the solar system thing, though. Let me do the solar system thing, and then I'm going to do Purple Rain, and then it's going to be the weekend. Plan? Okay. Okay. Whew. I need to open a window, get some a fan. You know what? There might be a fan somewhere here around here, but I'm going to be okay. Let me get a little more water. I'll be right back. I can actually talk to you while I'm getting water because I have a wireless mic. I also am stepping into some cooler air for a little bit, which is nice. I'm in a kitchen now. I'm walking over to a sink. I'm turning on some water. You can probably hear that. I'm filling a glass with water. The glass is full. Now this is like my own poem. Getting water by myself, talking to the internet on a Friday. Okay. All right, I'm back. I kind of want to just do the Purple Rain thing. Because I want to make sure that happens. Let's do Purple Rain really quick. Then we'll do the solar system, okay? I'll do Purple Rain in processing. Why not, right? Okay. I'm just going to start. Yes, I do drink city water. That is correct. This is New York City tap water right here. Somebody give me, by the way, in the chat, somebody type me a good RGB numbers. I don't want the hexadecimal version. Numbers for purple. Good purple, okay? Okay, here we go. Things are recording. Oh, I'm going to put my timer up, even though that's quite unnecessary. Oops. Oh, wait. Oh, here it is. Guess I screwed something up. Forget the timer. Let's do the Purple Rain without the timer. I'm not going to worry about the timer. Okay. 255, 0, 100. Okay, thank you very much. Okay. So if you guys are having issues, ooh, there's another nice one. The hexadecimal won't do me any good, although I guess I could write hexadecimal in processing, but I'd rather have the RGB values. Thank you. Okay, so the one thing I'm going to do is put these in the comments. 138, 43, 226. Someone suggested 75, 0, 130. That's indigo. I need purple. Forget the timer, yes. Okay, so that, okay, got two good purples there. What's a good background color to go with that purple? Here we go. 230, 230, 250 for background. Okay. 230, 230, 250 background. Okay. Okay. So everybody, here we go. We are going to, in honor of Prince, we're going to make Purple Rain in processing today. Part of Coding Rainbow seems appropriate. Yeah, so here I go. I'm going to start this off. I think this is going to be short. And then I will make also publish a P5JS version of this too as well, okay? I'm going to start at some point. Okay. Reset my camera. Thank you, guys. I am recording. I am resetting the camera. And here we go. In 3, 2, 1. Hello, welcome to another coding challenge. Today, in honor of Prince, I am going to program, or attempt to program at least in some amount of time, hopefully a short amount of time, Purple Rain. Okay, so I have, only thing I've done to prepare is thank you to the internet for the suggestions of a good purple color and a good background color to go with that purple. So let's get started. So the first thing that I want to do is just add a setup and a draw. And if you're wondering where this is that I'm typing, this is something called processing. Link to get processing will be in the description to this video. And I'm also going to make a JavaScript version of this example using something called P5JS. So you'll see in the description of this video code for both processing and for JavaScript for the browser. Okay, so now the first thing I need to do is create a size for the window. I'm going to say 640 by 360. And then I want to do a background. And I'm going to pick this nice background color that was suggested in the chat. And I'm going to run this sketch, and I'm going to see here, there's my nice background. So I need more space here. I didn't plan this out. Move this over and see this, and here we go. Let me start over, everybody, because I like. This is an important video. I'm going to start over, because I want to have the size of the processing window correct in the video and not be doing that live. Okay, sorry for the people watching live who are now going to have to watch me do this for 10 seconds again. Stop. Also, I want to actually start this timer to see how long I'm doing this for. Hello, and welcome to another coding challenge. Today's coding challenge, I liked having it zoomed in on this. Really lost it. Okay, everybody, here we go. This is going to be it for real this time. Hello and welcome to today's coding challenge. Today I'm going to make a purple rain in processing in honor of Prince. So the only thing I've done to prepare for this so far is pick two colors which were suggested by the internet. Thank you very much. A purple color for the rain and some other color for the background. I am using the processing programming environment. You can find, if you're coming to this video without knowing what processing is, check the description to download processing. This is, the code will be written in the Java programming language. I'm also going to make a JavaScript version using something called P5.js. So if you want to run this example in the browser on the web, you can find that version of the code as well in the description of this video. Okay, let's get started. So the first thing that I need to do is just write a setup function and write a draw function. And then I'm going to add the size function. My glasses are falling down on my face. The size function, and I'm going to take this wonderful color suggested and say background. And I got an extra parentheses here, and I need a semicolon, and I'm going to run this. And look at that, there we go. So this is the start. This is the scene. This is where I want my purple rain. So to make rain, I think probably a good way to do that would be to create a single object, which is a raindrop, and then from that object, make an array of many of those raindrops. So the first thing, to do that, I think what I'll do is I'm going to go ahead and make a new tab. I'm going to call it drop, and then I'm going to say class drop. So a class being a template for making objects in the Java programming language. In the JavaScript version, this will look like a constructor function. You'll see that. And I'm going to say this drop is going to have an x, and this drop is going to have a y. And then I need a function for the raindrop to fall, and a function for the raindrop, I'm going to call it show, to be rendered on the screen. So what do I want my drop to look like? Let's have the drop be a line. I think that might look like rain. A line at x and y to x and what? How about y plus something, right? So how about like y plus 10? And then I want to have that line be what? Purple. So I'm going to go get the purple color right here. Come back. And then in fall, I'm going to say y equals y plus y speed. Okay, so y speed doesn't exist, so I'm going to create that as a variable. So now that I've made this object, this is the core idea of the drop object. It has an x and a y speed for falling, y equals y plus y speed, it falls, and then a line to draw it. Now, the drop needs to have initial values for these variables. So I'm just going to, by default right now, have a drop that starts in the middle of the screen, have a drop that starts at the top of the screen, and have the speed be equal to 1, just to make sure things are working. And then here, what I'm going to do is create a variable, drop, d equals new drop. And then in draw, I'm going to say d.fall and d.show. So I think that's enough code to write that I should test now. I have a drop class. All the code for the drop. I have the drop object. Let's run this, and let's see our individual purple drop. There it is. Purple rain. There's the purple rain falling. So it's only one drop. So clearly what I need to do is have many drops. So in order to have many drops, I want to have an array. And the way that I'm going to do that is by changing this to be an array. Now look at this. The array syntax is the kind of thing, a drop with the brackets, equals a new drop, and I'm going to have an array with 100 elements of it. So now, instead of making one single drop, I loop. I think this is maybe the 1,000,000th time I've typed that loop in my life. I'm going to loop through the entire length of the array, excuse me. And I'm going to say drops, index I, is a new drop. So I'm going to make 100 new drops in that array, and then there should be more dancing. Like, I'm not going to be good enough to dance, but there should be more dancing involved with this particular example. So while I'm programming this, I'm going to then go down into draw, and I'm going to say drops index I dot show. There should be music playing, at least drops index I dot fall. It doesn't really matter what order these are in, but I'm going to put fall first, and so that's what I had before. And now we're going to run this. And there should be 100 drops in the window, but there's still only one. The reason there's only one is because all of the drops have been are at the same exact spot, moving at the same exact speed. So I need to do something to randomize them a little bit. So one thing I can do is give them all a random location. And we can see what happens there. Now we can see, look, all of my rain is falling down exactly together. Another thing I could do then would be to say, well, why don't I give them some random y locations? And why don't I actually have them start off the screen? So their random location should be between like -200 and -100. So they're kind of way off the screen. And now we can run that, and we'll see this should be a little bit better. Look, okay, now we see the rain is the rain in Spain falls mainly on the plain, that things are spread out a little more. I don't like the speeds. I think they all should in general be a lot faster, but I could give them different speeds. And we can see, there we go. Now we can see we've got a lot more stuff going on, but the rain sort of fell and then was gone. So I think it would make sense in this case to do something like say, if y is greater than height, then set y back equal to somewhere randomly up high. So each raindrop should reset back up to the top. And here we go. So you can see here we've got something that looks a little bit more like rain. Now, I think there's quite a bit that we could do to make this better. But this is a good start. Add some music, dance around your room to some Prince songs, and you might feel a little joy in what is a sad subject, I guess. I don't know what I'm talking about. But I'm making purple rain, which is what I'm doing here today. Okay. So let's try to add a few more things to this, just to make it a little bit nicer. So what are some things? One thing is, boy, we should really have a lot more rain. That's good. I like this. I like seeing a lot more rain. We should also perhaps think about a couple other things. One is this being something variable, like how long is that line? So I'm going to make a variable called length and have that be randomly between 10 and 20. So I'm going to have, you're going to see now that the raindrops are of variable length. That's pretty good. The other thing that I'll add, what else could we add to make this better? One is that I wonder if actually having the raindrops fall to look like they're experiencing a little bit of gravity. Right now they're falling at a constant velocity. So I could do something like y speed equals y speed plus 0.05, some amount of gravity, so that speed keeps increasing as they're falling. And then of course, y speed needs to get set back to 0 when they get reset. This might give it a bit more of a realistic feel. Whoops. What just happened? Oh, you know what's happening? Why did that? Oh, no, of course. Because the y speed, yeah, it's good to give them like a little bit of a random speed. So, okay, so this is given, it's not, sorry, I set their y speed all back to 0, so that's why they all started falling down in sheets together, because they all started exactly the same speed. So I think a little bit of variety is good there. And I'm going to actually make the gravity a little bit stronger, just to sort of see if we can see it more. Yeah, you can see how that looks a little bit more realistic. It's, it'll get, as the stuff gets spaced out, it's a little bit better. I think it would probably be good to give it a much bigger range for where they can start so that things are already spread out at the beginning. There we go. So you can see here's the rain kind of falling more in sheets with some gravity with different sizes, with different lengths. Now, I think there's one more thing we could add to this to make it feel a little bit more like rain in a three-dimensional space, right? We could create a kind of pseudo-parallax-like effect. Like things that are closer to you are going to appear if they're falling faster, and things that are further away are going to appear if they're falling slower. So we could increase the stroke weight and the size and the speed with the same variable. So what if I gave every drop like a z value, which is some random number between like 0 and 20. And so the length, 0 being far away and 20 being close. So I want to map that z value, which has a range between 0 and 20, to a length between 10 and 20. So this would mean that if it's longer if it's closer, and it's shorter if it's further away. Okay, so that's good. And then the speed also should be not random, but y speed should also map z, which goes between 0 and 20, to between what I have at 4 and 10. So the closer things are faster. And then when I reset the speed, I should reset it the same exact way, according to z. And then also, one thing I could do is I could add stroke weight. And I could make a variable called thick, and I'm going to map z, which goes between, as we know, 0 and 20, and it should be 1 pixel wide when it's far away, and 2 pixels wide. Maybe I'll make it 3 pixels wide when it's close, and then stroke weight thick. So this is what I've done. I have made things that are, there's no actual 3D, but I've created a variable so those things are randomly between 0 and 20. When things are 20, they are thicker, faster, and longer. When they are 0, they are thinner, shorter, and slower. Okay? So here we go. Let's see how that looks. It's probably not extreme enough. And I wonder if the gravity should also be mapped. So let's make the speed much more extreme. I'm just curious if that really makes a bigger difference. I don't know if it's actually, oh, because of the, let's take the gravity out for a second. Yeah, so you can see the effect is much stronger. You can see the effect is much stronger without the gravity. So I don't know, I'm trying to get the two, so I think probably what makes sense is for the gravity to also map z between 0 and 20, between 0.01 and 0.2. I can actually make it between 0 and 0.2. And so that gravity should also be mapped according to that z value. Okay, here we go. So I don't know how well I made Purple Rain, but this is my version of Purple Rain. I clearly am no visual designer genius. I hope that you will take this code, make some nicer Purple Rain. An exercise could be to have little rainbow splashes at the bottom as the rain hits the bottom. With little particles that burst up. Maybe I'll add that and post a version that has that as well. But here we've made today Purple Rain in what is about 12 minutes or so, I think. Thanks very much for watching. If I knew the lyrics really well, I would recite them right now, but I'm afraid of getting them wrong. I certainly don't want to say Purple Haze, as has happened before. So thank you very much for watching, and see you in the next video. Okay. Oh yeah, I should definitely make a video in French. Now everything's in French now in the chat. I don't know if this was any good. I kind of want to do this again. I don't, but hopefully you guys enjoyed that. Okay, so I said I was going to make a solar system generator. So let's do that also, since that was kind of short and I feel like I've got energy to go another 15 or 20 minutes. Anybody have any comments or thoughts or suggestions about that particular video? Oh, yeah. So a couple questions in the chat. Could you post the code somewhere? I will absolutely post the code somewhere. The code goes, I'm going to actually probably, the code goes to, oops. I just can't do this right now. Actually, I wonder if I can. It might actually let me drag a folder now. So am I logged into GitHub? Hold on a sec, everybody. So I'm going to create a fork of this because I'm in a different account. And I'm going to go into 10-minute challenges here. And I'm going to go to desktop. I'm going to try to upload the code right now live. Where did I save that, by the way? Save as. Oh, I just saved it in the processing sketchbook. Documents, processing 3, Purple Rain. Is it gonna what's the chance it's going to let me do this? Ah, look at this. Look at this. I'm uploading it right now, adding Purple Rain example, and commit changes. And then I am going to do a pull request and say create pull request and do create pull request. So it's uploaded in the Rainbow Coders fork, and as soon as I log back in, do I still have that open? I don't have my GitHub account logged in. I'll merge that and the code will be there. Okay. Oh, having the rain fall at various angles would make it pretty. Well, how come I couldn't think of that? That would have been good. So some people are asking, having the rain. Okay, so some people are asking, what did I study in university? I studied math and philosophy. That was my major. How is the processing code different from Java? It actually is not different from Java. It is Java. It's just kind of processing as a development environment has removed some as behind the scenes as when you run your code, put some Java wrapper stuff around. Like it makes this a class and it puts the main function, all that stuff. But processing is really just a set of Java libraries and a development environment for writing Java code. Is there a way to sync a fork from the GitHub UI? I'm not exactly sure about that. That's a good question. So I think what you mean is we see how you could do a pull request, but could you, if a repository goes ahead of your fork, can you pull those changes back into your fork as well? I wonder if you just click fork again if it would do it. I would have to look into this. I actually don't know, but because I always do this with terminal. It'll be interesting to see if you can. I don't believe that you can do that with the UI, but maybe you can. The UI does so much now. Okay. I don't know a lot about Java FX, but I hear that it has really nice high quality 2D rendering, and actually processing 3 has, is this it? Yeah, has a special renderer that you can unlock by selecting FX2D that renders with Java FX. But you should tread carefully because it's a kind of it's in development. Okay. Great. I'm so glad to see all these new listeners here. Okay. All right. So sorry, I'm reading some comments. Okay. Now let me close this, and we're going to make. I'm going to make the solar system generator. This one's going to be a much harder project. And now, interestingly enough, one way of approaching this, and I'm actually going to open this up, which I think, sorry, I'm just looking for a particular example. Yeah, this example, I think. So this is an example that I have for processing, which is, it's kind of like a solar system generator. And you can see that it's in 3D. These spheres are kind of orbiting this planet. Now, this particular example is using an actual formula for gravitational attraction. So it's actually simulating the physics. But I think what I'm going to do in this particular video, coding demonstration, is I'm going to program it just using translate and rotate. So I'm going to have just used sort of rotation to have things rotate around something. But it is, I think, good to reference this, and maybe the video will open with this particular image behind me. The default processing renderer is just a software renderer. It's Java 2D. It's like the Java renderer. And then there's P2D, which uses OpenGL for 2D drawing, and then P3D, which uses OpenGL for 3D drawing, and then the FX2D. The code for the physics version is under. If you go to processing under File, Examples, Topics, under Simulate Gravitational Attraction 3D, and I cover how to do this in my Nature of Code book, just to plug things here if you want to just read it online or buy a copy of it. Okay, so hold on a sec. Let me open this up again. Let me minimize this. Put this here. Let me do solar system generator. And let me do this here. Let me zoom in on this so we can have this. OK, so I think I'm ready to do this next challenge. I am going to cycle the cameras. I'm going to drink a little. This is going to be my last challenge of the day, and then I'll be done. And, but I will maybe have time for a few questions if people have some other questions. Yeah, use Kepler's third law. OK, you guys, I'm going to do a quick and dirty version without using real physics formulas, although I think that would be great to actually do that in an example. And maybe someone will contribute one to me. Okay, here we go. Okay, here we go. I am ready to do this one. Why is it all white back there? Oh yeah. I like having some rainbow color in the background when I start. Stand in front of the rainbow. Okay, here I am. Ready for this, you guys? Let me check my the microphone battery. I still have 2 bars here. 2 bars there. So I think the batteries should be okay. And I should really, hold on. I should erase this because I might end up doing some diagrams. So let me have a fresh whiteboard to work with in this particular video. I wonder if I just move this light all the way back here. It's just going to be kind of more general light in the room, and that will be good. So that's a lot of shadow. Okay, I guess that's going to be good enough. Okay, how does this look? Okay. Here I am over here. The square of the orbital period of a planet is proportional to the cube of the semi-major axis of its orbit. Yeah, I should definitely do a Kepler's law one. That would be fun. Yes. So also in the chat, somebody asked, am I a teacher right now? Yes, I teach at a program. I should answer these questions after I do this challenge. But I teach at a program at New York University, a part of Tisch School of the Arts, and it's called ITP. I'm actually on a semester of leave right now, and I'm dedicating myself to making video lessons to see who I can reach and what I can do and if I can do a good job at this and if people are interested in it. So I'm trying to do these sessions once or twice a week and see how that goes and that sort of thing. But I'll answer more questions about that if you guys are interested after. Okay, here we go. Ready? Coding challenge, I don't know, whatever. Hello, welcome to another coding challenge. In this coding challenge, I am going to program a solar system generator, kind of like this one. Now, this one that you're seeing over here, it's over here, I think, yes? That one is an actual example that you can find if you download processing and look under examples, topic, simulate, forces 3D or something. Oh, shoot, what is it called? Gravitational attraction 3D. Oh, it says it right there, too. Okay, I'm going to start over. Everybody bear with me. Okay, try again, one more time. Hello and welcome to another coding challenge video. In this video, I am going to attempt to program a solar system generator, simulator, system-like thing, just like the one you see over there, in 3D. I'm going to do it in a bunch of steps, starting with 2D and moving to 3D. I'm going to use the processing development environment, which you see right here. Link to download processing will be in the description of this video. Now, you might be asking, why are you doing this? Look, you did it already. This, in fact, is one of my examples. It is called Gravitational Attraction 3D. It's one of the examples that comes with processing. This is actually doing a simulation of a solar system-like thing with the actual formula of gravitational attraction. I will link to a video from my Nature of Code series where how to make this is explained, but I'm going to do it in a different way, which is really ultimately a lesson about transformations. Translate, rotate, push matrix, pop matrix, how those types of things work in object-oriented programming, in processing. And so I'm going to do it in a different way, and hopefully by the end of this, somewhere between 10 and 20-minute video, you're going to see how to use all that stuff and make yourself a little solar system, and you will be much more creative and interesting at doing it than I will be, and hopefully you will share what you do with me then too. Okay, I got to get started. Let's get started. So as always, I'm kind of just got a blank slate here. I should really at least enter this in beforehand, but I'm not. I'm going to add setup, and I'm going to add draw, and I'm going to add size. 600, 600, and space is a dark black place. So I'm going to just use background 0. I'm going to run this code. I'm going to move this over here. Here we go. This is my outer space simulator. Do you like it? Very few lines of code. Okay, now the first thing I want to do is create an object. I'm going to call it a planet. So I'm going to make a planet class, and I really think it's going to be useful here for me to use p vectors. So I'm going to create a p vector, called position. I have to think about this while I'm doing this on the fly. I'm not so sure about this. And I'm going to say, when I write the constructor, Yeah, the constructor is going to get an x and a y, and that position will be a vector at that x and a y. Now let's think about this for a second. Oh, and create vector is a function that's in p5.js. I'll just say new p vector here. Okay, I got to think about this a little bit more. I have a marker here. Let's think about this. So what I want is I have a planet object. And the planet object ultimately, so let's just think, let's imagine the first planet object I'm going to make is like a sun or a star. And then I'm going to make another planet object. And what are the things I need to keep track of? So I'm not going to do proper orbital mechanics, Kepler's law stuff. This is a great topic for another video. Encourage me to do that. I would love to look into that and do that more. But it's not going to be in this particular video. But what I need to keep track of is its distance, I'll call r, from the planet. And it's going to rotate around in a circular orbit. So in order to use the rotate function in processing, I need to keep track of an angle. So actually, what this planet really needs is not an xy location, but a radius and an angle, or really a pole. This is the idea of a polar coordinate, by the way. So instead of xy, a radius and an angle. And you know what? Forget about this p vector stuff. I was really thinking along the lines of my four-space simulation, which I do have other videos that you could look into. And I think what I'm going to do in this planet is give it a radius and an angle. And so just to start, we can fill it with radius. And I'm going to say, sorry, I lost my train of thought there. The radius equals r, and the angle always, let's just say it always starts at 0, or it could be a random angle, that sort of thing. So I definitely need to have a function to draw this. And what I'm going to do to draw it is just draw an ellipse at 0, 0. And I'm going to make, it should also have a size. So I wonder actually if radius should actually be the size of the planet. And I should also have a variable called d, which is, I'm going to call this distance. I'm just going to make it longer-winded. Distance, oh, losing steam, it's been a long day. Distance is the distance from the sun. Now, what I'm trying to do, by the way, is think of a generic model. Because I might have a bunch of planets that have a distance from the sun, but I might have other planets which are essentially like moons, which have a distance from their parent. So I might have this like tree-like structure where some planets rotate around the sun, other planets rotate around the planets. So really this is just like a body. This is like a celestial body object. It's not really a planet object, but I'll just call it planet for simplicity. Okay, so back to here. So I'm going to draw an ellipse at 0, 0 with the radius, which is not r, whoops, radius times 2. So let's just see. Sorry, I'm anally retentively getting rid of all the extra space. Here's my planet object, a radius, an angle, a distance. A radius, a distance, an angle, and a show function which draws it. So what I want to do is create a planet. And I realize the sun is not a planet. And I'm going to say sun equals new planet. Its distance from anything else is just going to be 0, because it's going to start in the center. And then I'm thinking, its size, that's what I need, it's going to be 100. And then I'm going to have sun.show. And let's run this. And where is it? Now I have a feeling, number one is I didn't give it, let's give it a color, fill 255. And what am I missing? Distance should be 0. Radius should be 100. There we go. Now notice where it is. It's in the top left. So I want my sun to be in the middle of the window. So I'm going to start by saying translate width divided by 2, height divided by 2. I've got a light that keeps going on and off up there. It's a little disorienting. Okay, so here we go. We're getting somewhere now. We've got the sun in the middle of the window as an object. So now, clearly, I need more data structures to store the information about these planets. Where should those go? Well, I have an idea. You might think that ordinarily the next step that I would do would be to create a planet array, right? Because ultimately, I want to have a lot of planets. But really, this is my data structure. I have a sun, and the sun might have 3 planets rotating around it. And this planet might have 2 moons rotating around it. This might have 1 moon, and that might have no moons. Well, each one of these is a planet object. So what are the properties of a planet object? The properties are, oh, dramatic moment ruined, radius, angle, distance. Radius, the size, angle, where is it in its rotation, and distance, how far is it away? And also, children planets, things that are rotating around it. So the sun has 3, this has 2, this has 1, this has 0. So each planet should, inside of itself, recursively, self-referentially, store a reference to an array of planets. Now, I'm going to be very simple about this and just say every single planet gets 3. Okay, so I got an idea. Hold on. There's lots of ways we could approach this. But I think what might be useful right now is for me to write a function. And I'm going to call it spawn moons. And in the spawn moons function, I'm going to create that array. So maybe I can create a certain number of moons. I can say planets equals a new planet array with some number of moons. And then for int I equals 0, I is less than planets.length, I plus plus, planets, index I equals a new planet. And maybe each moon should be, half the size of the planet. This is totally arbitrary. This could all be random, and I figure out different ways of doing it. And then its distance should be some amount. So I'm going to say, I'm also going to say distance, and I'm going to say some amount like, I think maybe we could actually make this an argument here. No, let me try just doing something random for right now. Try doing something random right now. Random, 100, 200. I got to figure out a better way of thinking about that. So each, and I kind of want to put these as separate lines of code to make this easier to see. Okay, so when a planet gets a bunch of moons, it runs through a loop and creates all of them with a smaller radius and some distance away from it. So what I want to do here now is say sun spawn moons, and I want to have 5. So I make a sun and then immediately say spawn moons and have 5 of them. We could just run this. There's no errors, but I'm not seeing anything. Why am I not seeing anything? Because when I show the planet, I also need to show its children moons. So, and remember those children moons, I should call them, I'm calling them planets, I'm calling them moons, whatever. The children are just planet objects. So when I show this particular planet, I draw it as a circle, then I loop through and show all of its subplanets. So let's see that. And okay, so we have a null pointer exception. Why do we have a null pointer exception? Let's think about this. So what's null here? Let's print line planets. And actually, let's say print array. And so we got to debug this here. OK, so it looks like the array has, so why did I get null for, that's weird. Hold on. 0, 1, 2, 3, 4. What's planets.length? 5. What's null? I'm losing my mind here. This part might get edited out later. Weird how I'm getting a null pointer exception, and yet it seems to be working. Like, hold on. No null pointer exception. Oh, okay, hold on. Sorry, everybody. I'm sure. Okay, so that's working. planets index I equals new planet. Something must be, spawn moon's not happening? Oh, I meant, no, this seems right. This seems right. Okay, hold on everyone. Let's see here. Let's make sure this is happening correctly. Print line planets, index I. Let's run this. Right? 5 planet objects were generated, so those are not null. Oh, I know what happens. Oh my goodness. Ah! So because of this whole recursive system I have, oh, of course, there were people watching this live, or probably you've all been yelling at me for the last 30 seconds. Because of this recursive system I have, I say, hey, planet, show yourself, then show your children. Boom, boom, boom. And each of you children, show your children. And each of you children, show your children. Oh, you don't have any children? No pointer exception. So at some point, one of the planets will not, that array will be null. So I need to make sure that I check that. So all I need to do here is just essentially say if planets is not equal to null, meaning if this planet does have some moons, if it has some children, only then call show. So that's just a quick little check. Everything was right. I was creating things correctly, but I'm forgetting that the new planets I created also have arrays. Okay, let's go and let's run this. Wonderful. So you can see, I see one circle and I see a bunch. Now, what am I missing? So what I'm missing is a crucial key step, which is that if I have the sun and I have a planet and it's supposed to be at a certain distance from the sun, the orbital distance, I need to use a function in processing called translate. But what translate will do will say, I drew the sun at this location, then translate out this far, and then draw the next planet. So I need to add, right, everything is only just being drawn at 0, 0. Oh, I'm in the wrong place. Everything is only being drawn at 0, 0. So I need to add before this, translate by r, comma 0. And I also want to rotate by some angle. Okay, so I'm going to rotate by some angle, which is, and not by r, by distance. Okay, so now if we run this, we should see here are the planets. And let's do something to make things a little more visible here. Let's give the color some alpha so we can sort of see what's going on. Let's also think about how far these planets are from a couple things. One is, let's make the sun quite a bit smaller. And let's make the planets, between 75 and 150 in terms of distance. And you can see, now how come there's only 2 of them? There should be 5. Now, let's think about why I'm not seeing 5. Let's take a look at planets.length. 5. Okay, I think they're just, I'm being silly because they're getting spawned off the screen. So we're not seeing 5. So let's, sorry about that. That seems kind of obvious to me now. So let's just, randomly put them between 75 and 100. This is, did I do the distance? Oh, of course. Oh, yay. The next thing that I need to teach you guys about, in terms of the important concept, is I completely forgot. So translations, doesn't matter what I do, translations are cumulative. So I draw the sun, then I translate by 75, and I draw the next planet. Guess what? Let's say the next one got picked 85. What I want is to go back to the center of the planet, translate by 85, and draw the next center of the sun, translate by the next one. But actually what I did was I translated by 75, then I translated by another 85, which I don't want to do. So this is where object-oriented programming and push matrix and pop matrix come in. If in my object, if in the show function, I always put at the beginning of the show function push matrix, which is like a save, and at the end of the function, I put pop matrix, which is like a restore. This function becomes sort of its own thing, its own world. Whatever translations and rotations happen inside of here, they get undone the moment I say pop matrix. So whatever translations happen for this object, they don't affect any of the other objects. And you can see now, that they're all, of course, bunched up right there because I kept trying to reduce the amount, where really what I want is for this to be between, like I said, 75 and 300. So now you can see I'm picking some random planets. Now, notice they're all along the x-axis. Why? Because my angle is always 0. Let's change that. Let's make a random angle between 0 and 2 pi. Oh, wait a second here. What is going on? That should not have happened. Let's look here. Angle, float angle. That's crazy. Why is it picking one angle for all of them? What did I do to deserve this? Strange result. Translate, then rotate by the angle. So let's hold on. Let's take a look at this angle. We don't need, we can get rid of this print line planets.length. I have a feeling I've missed something rather obvious. So it's getting different angles for each one, but somehow the same angle is being used here. Do I have a, no? Okay, hold on. Let's just change the variable name to make sure I'm not losing my mind. What did I miss here, everybody? Okay, hold on. This is certainly confounding me here. I gotta have to figure this one out. Oh, translate by the distance, rotate by the angle. Oh. No, that's right. Oh, wait a sec. No, that's right. And then come back, translate by the distance and rotate by the next angle. That seems to make sense. Hold on, I'm going to do a couple things. I'm going to say no loop, and I'm going to just make 2. This is a good way to figure this out. So the loop is only running once, and then I'm going to take out this print line, and I'm going to, oh, guess what I did? So important. Oh, these mistakes. I always make these mistakes. Oh my God. I'm rotating after I translated, which is absolutely incorrect. In this case, I mean, you could be doing that, but let's think about this, right? What I want is, here's my sun. I want to, and I'm right now, my sort of registration point where the world is, my point of view is the center of the sun, and the angle is 0. So what I did is I translated out, and then I rotated, which was meaningless, and those things were actually appearing at a different angle only because the sun also had its own rotation. But what I want to do is not that. What I want to do is the following. I first want to rotate, and then I want to translate out. And then I'm going to go back and rotate again and translate out to get them in different spots. So the order of this stuff is so unbelievably important. And I made a classic error. I want to pretend that I did it on purpose, but I did not. So I'm going to put that there. I can get rid of all my print lines, and we can run this again. And we can see, there we go. And there's only 2, so let's go back and give me 5 again. And let's get rid of no loop, and let's run it. And we can see, OK, we've got our solar system. We've got 5 planets and 1 sun. Now, we should also add a function. I'm going to add a function called orbit. And in this function, I'm going to say angle equals angle plus orbit speed, right? Because I want the angle to change so that they rotate around. And I'm going to replace theta with angle everywhere to just use angle. And then I also need another variable, orbit speed, which I am going to make random. Orbit speed equals random, some speed between 0.1 and 0.3 or something like that. And now let's run this. OK, angle, orbit. Let's use the camel casing. Oops, or whatever. It doesn't matter. Just have to be consistent. Everything is case sensitive. So now, oops, a float distance. OK, and now I also need to add in, ooh, interesting. So if I say sun.orbit, I'm asking the sun to orbit. But what does it mean for the sun to orbit? Well, it needs to do this, but also, and why is angle now not knowing what it is? Oops, I lost angle. Sorry, everybody. Angle. And now, what do I need to do here? Whenever the sun orbits, Oh, come on. Like my keyboard is going crazy. Whenever the sun, just like when I show the sun, I have to show all of its children. When I orbit a planet, I need to say, as long as there are planets, right? I need this if planets is not null. Then I want planets index I.orbit. I want all the children planets to orbit as well. I don't have a timer. Okay, we can see something crazy is going. Okay, so let's think about this. So first of all, they're all kind of spinning out of control. So something has got to be wrong here. Let's look at, I've got push matrix and pop matrix, which would lead me to believe, oh, so one issue is that I have the sun spinning as well. And I don't want the sun to spin. So I just want the other things to spin. So, and things are spinning kind of quickly. So the issue is I really should make the sun probably as this like static object a completely separate thing. But what I'm going to do is add a argument here, which means that I can set the orbit speed. And when I make the sun, I'm going to set the orbit speed to 0. And when I make the other planets, I'm going to pick a random orbit speed. And now that should fix it. There we go. So we can see, look, everything is rotating, and those speeds are quite fast. So let's pick much smaller random numbers. And you can see, okay, so now we have a bunch of circles all spinning around the center circle. Pretty good. They could have different sizes. They could be more. We could do more variety with the speed, but we're getting somewhere. Now, to really make this magical, right? Nothing that I've done here right now is the two things that I want to do to make this magical is number one, have planets have planets have planets, and number two, make this happen in 3D. So let's see if we can. If you still got some, pause this video, go outside, take a walk. I don't know. Then come back if you want to watch it more, but I'm going to keep going with this. Okay, here we go. So the first thing that I need to do is say that, when I spawn moons, what I want to do is have my planets also spawn moons. So if I were to write this, so if I were to write like this, for example, so the sun gets made and the sun spawns a moon. Then I make new planets, and each of those planets spawn their own moons. And so each object has an array of other objects, an array of other objects. So while this would work, this would result in an infinite forever loop, because every planet would make 5 more planets, which would make 5 more planets, which would make 5 more planets, which would make 5 more planets. So I need some way of having an exit strategy. Here's a way that I propose, which is really dangerous, actually. I probably shouldn't do this, is, well, first thing I'll do is just, I'm trying to think of a good way of, there's a bunch of different ways I could approach this. I could keep track of levels. So I could say like, okay, well, after I've spawned, like after I'm on the 5th orbiting planet, forget about it. I could also right now just like only do like the sun with some planets and those planets have moons. Like I don't need those moons to have moons. But I also could sort of like randomly decide if planets get moons or not. And I would by chance eventually have this stop. Let's do the levels thing. So what I'm going to do is I'm going to add a second variable, spawn moon 0, meaning I'm at level 0. So I'm going to add an argument called level. This is going to be useful too, because level is going to help us determine the size and speed of these maybe. And then I'm going to say level minus 1. So when I spawn the moons, oh no, plus 1. So the sun will call spawn moons with 0. And then it'll make a bunch of planets that will call spawn moons with 1. And they'll make a bunch of planets. I've been doing this for half an hour, I guess. They will spawn a bunch of planets with level 2, and so on and so forth. So I only want to do this if level is less than 2. So let's actually only do this if level is less than 1. See what happens. Whoa! level is less than 0. Yeah, that's interesting. So why did it even do it? Oh, right, because I'm already spawning 1. So this is if level is less than 0, I'm getting these 5 planets. And if level is less than 1, level is less than 1, all of those planets have things orbiting in it. Now, this is totally out of control because the distances and the sizes are all over the place. So what I want to do probably is figure out, number one is figure out the number of moons they should have. And maybe I'll make that random. And it's going to be between 0 and 2 and 4. And so it's going to have that many. So number one, this, right now you're going to see there's a lot fewer things, right? And also the distance, like the submoons should be much closer to those. So I can use this level variable quite effectively. So level, so I'm picking random distances, and what I could do is divide by level. So first of all, I'm going to make the level 1. Start with 1, because I don't ever want to divide by 0. And I'm going to have the distance be divided by level. And also the radius, I'm already multiplying times 0.5. So I could also, I could also say divided by level. And that way, this should now be 2. And you can see here, now look what's going on here. It's sort of hard to see because I don't have like a good sense of sizes. So I guess divided by level, I started with 1. So I should say divided by level times 2. There we go. So you can kind of see here, if I zoom in, what's going on. This particular planet has its own thing orbiting around it as it orbits. By the way, they all only orbit in one direction. Not the band One Direction. Insert One Direction song right now. That orbital speed, I really should pick, where do I pick the orbital speed? Right here. I should really pick some value also that could be negative so that they could spin the opposite direction. So you can see now, and it's sort of hard to tell what's spinning around what, but you can massage the values and stuff yourself. Play with this, because I got to move to 3D, but I at least want to see that I could have another level here. And can we find it? I think I've shrunk stuff too much. So let me at least see if I can get you, let's make things generally just quite a bit closer. And also, let's not have the size be that radically different. So you can see here the multiple levels of moons. I'm going to try to zoom in here. So you can see the multiple levels of this thing rotating around that thing with that thing rotating around that thing. And I could even add one more level if I wanted to be so crazy, like 4. And I'll let you enjoy this on your own to try to see like everything rotating around everything. Now, okay, so I would encourage you to take this, add some color, think about the distances, the values, the ratios, all of that much more thoughtfully. But this idea of nesting systems is kind of interesting to play with. Let's at least see if we can move this to 3D. And what I'm going to do is I'm going to do save as solar system generator 3D. And the nice thing about this, oh my God, I've really... No, I think we're going to be okay. I just realized, oh, this is the thing that happens in life. You think like, oh, I did this in 2D, and now I'll just do it in 3D. I'll just add the z-axis, no problem. But so many things start to happen. But let's go back. Let's get this into a stable place. Let's keep this down to 2 levels. And actually just 1 level right now, just to sort of see. So this is 1 level, and maybe we can make that starting distance a little bit bigger. And also just have... start with just 3. So at least let's try to take this and move it to 3D. Okay, here we go. Boy, this is much too long. These coding challenges just say, I don't know. Anyway, but maybe you're enjoying this. I can't tell. Okay, so what I want to do is, first of all, I'm going to say P3D. So the first thing I need to do is I need to be working in 3D. I mean, one thing I could do just to make sure everything's okay is in P3D, just run the same exact thing. So this, by the way, works in P3D. You can see, you can draw 2D stuff in P3D. The main thing I want to do is change these things right here. Instead of ellipse, I want, and why did I say, oh, to make a sphere radius. So let's look at that. So look at that. you can see there they go. Now I've got spheres, and you can see the stroke shows you this mesh, and the fill gives you like the fill in that mesh. So maybe what I'll do is I'll say, make sure I say no stroke, and I'm going to run this again. And you can see, look at that. There's even some like default shading stuff going on. I'm sort of surprised to see that, but I'm going to just add the lights function to see what that does. And I wonder if it's because of the alpha. I'm going to take out the alpha. Yeah, this looks more like what I expected to see. So now you can see I've got these three-dimensional shapes now rotating around each other. However, they're all just rotating around this flat two-dimensional plane. So let's really make this happen in 3D. And the nice thing about this is, I'm sure there's lots of really sophisticated quaternion math I could go down and try to like figure out. I would have a bad headache and my neck would start to hurt and I'd get a stomach ache. So I'm going to just do something simple. I'm going to do this. X angle, Y angle, Z angle, whatever. I'm going to create a whole bunch of different angles for 3 different axes. And then I'm going to, there's so many ways I could do this differently, but I'm going to say X angle, Y angle, Z angle, X angle, Y angle, Z angle. I could probably get away with just 2. And then when I draw the moon, I'm going to say, the planet, rotate X angle, rotate Y angle, and rotate Z angle. But I'm going to rotate X to rotate along the X axis, rotate Y, and rotate Z. What this means is, okay, I am the Y axis. This is the Z axis. This is the X axis. So if I'm rotating around the X axis, I'm doing this rotation. If I'm rotating around the Y axis, I'm doing this rotation. If I'm rotating around the Z axis, I'm doing this rotation. So all those different kinds of rotations can happen in 3D. And now if I run this, you can see we've got lots of crazy stuff. They're all right. Now everything is rotating, I just realized, with like the same speed along all, we're getting these like crazy things. So probably what I should do in terms of like adjusting the in the orbit function is I should actually just pick one axis to change the angle. And let's see what this does. And this is kind of doing something. Oh wait, boy, oh my God. See what I mean? 3D is a horrible place. Let's never go there again. I knew I didn't want to go there. This is why, because if you think about it, what I really need to do is, I'm surprised this visually is looking so weird. Because do I have my rotates in the right place? Because I rotate and then I translate out. Should really still, I would imagine, oh no, because I've got kind of like this vector. I need to rotate that vector. Ugh. Oh, I have to do this in a totally different way, which I can do, I swear. Should really, but this is, this video is going to cut out earlier than this. Some people are, yeah, they have gimbal on. I knew I had to do the stupid quaternion thing. This is pretty interesting, though. You can come up with something. I knew this simple solution wouldn't work. But let's at least add another level. Oh, a disaster challenge. So let's at least add this another level. Where do I do the spawning? Here they go. Let's add some more and see what happens. So you can see now we've got something going. So I need to be, I think what I need to do is, I think an easy way to approach this problem would be to, I got a good idea. That's going to be just like a trick. Because let me try a few tricks here. Okay, so let me put this back to 1. I want to at least get this. I don't want to go down the doing this the Euler angles or quaternions way. So I'm just going to spawn 1 moon and see what it does. Now I got something kind of accurate there, but remember we're going to get random values each time. So let's try running this again. Yeah, I don't know why I got things that looked so weird before. Let's hold on. The distance, by the way, should just be related to the radius, I just realized. Yeah, this looks good. Seems to be doing what I want it to do now. It just sometimes, I guess sometimes if I pick a weird set of angles, then it's going to, like it could rotate like this as opposed to around. So let's try doing this a different way, just out of curiosity to see if it works better. I'm going to create a vector. And I'm going to comment this, I'm going to forget about these angles for a second, and I'm going to say v equals p vector dot random 3D. So I'm going to get a random unit vector pointing in a three-dimensional direction, and I'm going to scale it by that distance. So the distance, so I'm going to just have a vector, and then this is going to allow me to translate right here, where I do translate. I'm not translating just by the distance along the x-axis. This is much better. What is the vector? It's called v. I'm going to translate by v dot x, v dot y, v dot z. And let's just, right now, I'm going to only use rotate x for a second and see how that does, just out of curiosity. Right, okay, so this is the problem, right? So I have, what I need to do is rotate that vector. Oh, how interesting. Okay, I don't think the vector object has 3D rotation in it. But let's just say for a second, if I don't actually, if I just say v dot rotate by the angle, x angle. So let's try that. Whoa. By the orbital speed. Because, let's try this. There we go. I'm liking this better. Maybe? No. Because that is still the same issue. I'm rotating around. I need the vector to rotate. Growing z means, how do I want it to rotate? Yeah, you guys are all asking really good questions. This could be the nuclei. I could just call it something else, the nuclei generator. That's what I should have done. I like this idea of using a vector, though. Let's look. I'm getting into sort of advanced territory here, but one thing I can do is the p vector object. I think this is gonna work. The p vector object, no, I want the Java docs. Reference, processing core Java doc, yep. P vector, p vector, p vector, p vector. And I want to look at, actually, this is not exactly what I want to look at, but p vector rotate. So rotate only by an angle, right, okay. But I want to look at core p-applet and look for the rotate function. Because rotate, I can rotate by an angle along an x, y, z. I think this is what I want to do. Right? What this does is it takes a vector and rotates by that vector. Let's see if we can make this work. Okay, so what I'm going to do is I'm going to keep my unit vector. I can't believe I'm still here. Oh my God, it's 5:30. I really got to go. I'm going to keep my unit vector. I'm going to have a single angle now, back to a single angle. This is my last dash attempt. And I'm going to keep that distance idea. Hold on, I got a bunch of things going on here. I'm going to call rotate by the angle along the vector, and I am going to then translate still just by that distance along the x-axis. It's doing something. Okay, I kind of I'm close, I'm really close. I don't think this video is going to make it to be published. If anybody is still watching this, you can write hashtag like rainbow gimbal lock because I knew this would happen to me if I ever went down the 3D road. And the world's 3D programmers are all just yelling and screaming at me about what a disaster I am. But I also could try, if I translate along this vector, is that going to help me? Or do I think, I'm just like trying random stuff, which is really kind of a terrible idea. Let's try this for a second. Oh, I'm translating along the vector and rotating along the vector, which means it's not moving at all. Fascinating. That's really interesting. What if I do, what if I like swap some of these? Whoops, not that. Like if I swap the y and the x, I'm starting to like this. There we go. It's pretty good. Getting some interesting orbital mechanics here. Okay, so I got to wrap this up because, and I don't know if I'm gonna publish this one, but I'm going to figure this out later and come back and re-record this video or fix it, or maybe I'll just do the 2D version and stop there. And I'll make a separate video for the 3D one. I know I've done this before, which is crazy because I actually have the example with the forces that's working even better than this. But I'm at least going to now show you guys. Let's at least get a few of these. And then let's at least, over here, level is less than 3. There we go. We got some interesting stuff going. I kind of like this. We got some stuff going on. Things are rotating in weird ways. It's the nuclei amorphous blob space generator. There we go. Coding Rainbow Challenge complete. I'm going to look at the chat now and see if anybody has any suggestions. Failbow, yes. Try rotate angle y-axis. I don't know what that means. Isn't it the XZ plane? What plane do you want the moon to be rotated on? Yeah, use the vector as normal and rotate around that axis. Boy, these are all really good suggestions. I'm gonna later I will use these suggestions and fix this up and publish the working code for this, and then maybe I'll come back next week and re-record a video tutorial that can be permanently on display. Yeah, I'm sure somebody also, if you Google this, somebody's probably made this in processing countless times. And this is the second, or at least the third time I've tried to program something that I really didn't know about and just completely failed at doing it, which is, I guess, what happens sometimes when I'm doing these live stream things. I'm going to probably get going, but I'm curious if anybody has any questions they want to ask or last minute suggestions you want to paste some code that will very quickly fix this. You can let me know and I'll fix it as well. Yeah, maybe this kind of solar system exists somewhere. Yes, an alternate parallel universe. So it's also happy Passover, everybody. It is, I'm not having anyway, it's Passover. Happy Passover to those of you who celebrate. And if you have any questions, you can ask them now before I kind of turn this off and get going back for the weekend and day. And I'll be back next week sometime, Wednesday, Thursday, or Friday, and not Monday or Tuesday. Okay. Is there any way, so here's a question. Is there any way to have a default sketch that loads when you open processing? That's a good question. Yes, there is. So processing, by the way, has something called tools. If you go up here, tools, you can see there are some like basic tools that come with processing, and then you can make tool add-ons. And I believe somebody has made a tool add-on, which is like a template, so that you can have a template sketch open automatically already with like setup and draw. So that's not a built-in feature of processing, but that's something that you could either develop as a tool, and I'm pretty sure it exists already as a tool. If you want to look for existing tools, I can go to Add Tool, and we can look here and see, here's a bunch of the ones. So I don't see one right now that's like sketch templating. But somebody should make one. That would be a great idea for a tool. Did you work something in OpenGL and C++? I used to do a lot of programming in C++ and OpenGL. Probably this is like between like 2001 and 2003. But at this point, I mostly do stuff in JavaScript and Java, and sometimes OpenGL is in there. Happy Earth Day. Happy Earth Day to all of you too. I have not seen the processing subreddit. There are challenges there. That's great. I should do the challenges there. I have not worked with Joshua Davis's hype framework. One thing I have really wanted to do was get guests to come in and do like guest videos as part of my channel. I don't know whether I would like pay them to do that or people would just volunteer or how that would work. But Joshua Davis would be great to come in and do a hype framework. What do I think about open frameworks? Open frameworks is fantastic. It's a wonderful creative coding library for C++ with a lot of the same ideals and principles and strategies that you might find in processing. There is a little bit, in my view, there's a little bit of a higher degree of difficulty in working with C++, mostly in like getting your environment set up. You've got to work with Xcode or Visual Studio or some other development environment. But one thing I would say that if you are working on computer vision applications, there's a lot of amazing libraries out there that are native C++ engines like OpenCV and stuff for the Connect. And so Open Frameworks has a lot of add-ons and different things that work really well for doing that type of stuff. Cinder is another great example of another C++ creative coding framework that I have used. Do I have homework for you guys? Okay, here's your homework. Your homework is to do a pull request on my Rainbow Poem Git repository. Your homework is to solve my 3D solar system problem, or email me, or tweet me, don't email me, tweet me because I can't deal with my email. Tweet me to remind me to do it. It is to spread the word about my video channel to get more people to watch, and to think of more coding challenges that I could do next week that I'd be less likely to fail at. Yes, I'm starting to do, are there any books you would consider fundamental to any programmer? No. I would definitely not consider any book fundamental. I think there are some classics. There's like the Kernighan and Ritchie C book. I'm sure there's like a ultimate, iconic JavaScript book, or a processing book, or a Ruby book. I don't know what those are. Yeah, I wouldn't say there's one fundamental one. I'm looking for any more questions in the chat. Wow, there's 44 people watching. It seemed like a bunch of international people came on all of a sudden. Where are you in the world? And what time? What answer is it? And what answer is it? What time is it? What is that IDE somebody asked in Twitch? This is the processing development environment. Processing is a creative coding environment for visual designers and artists and more. It is beginner friendly. It is built on top of Java. And there is also Processing Foundation is a nonprofit organization that maintains processing. And there's also a project that I'm involved with that I do a lot of examples and tutorials for called P5JS, which is a JavaScript framework for doing the similar kind of stuff. Canada, Finland, Italy, Spain. Wow, this is amazing. So exciting. Okay, it is 5:45 p.m. There are two lovely small children waiting for me to go home and have dinner with them. So I'm going to leave and do that. And I thank you for joining. I thank you for bearing with me today with the failbow. That's the good hashtag, failbow. This is the hashtag for today's tweet, hashtag failbow. If you've watched this, if you stayed with this for this long, I'm amazed. I don't know what to do about that solar system challenge. I mean, it will live, everything I do in this particular stream will live archived forever on YouTube, my most embarrassing moments. But I don't know that that one's ready to be like published as its own video chunk, but we'll sort of see. And I'm gonna come back next week. Next week is a little bit of a tricky week. It's a school break week here in New York City, so I've got a lot of family obligations, so I don't know if I'll have as much time to do my streams, but so I know that I can't for sure on Monday. Wednesday is not a good day for me either. There's a chance I could do something in the afternoon, so I'm going to be picking probably one day next Wednesday, Thursday, or Friday, and I'm planning to continue my Git and GitHub tutorial series. Oh, and my phone is ringing. This is my home calling me. Definitely need to go, and other stuff too. Okay. Try to arrange timecode to cool shaders. I don't know what that time to code. Oh, shaders. Oh, see, you guys don't know me well enough. The 3D stuff terrifies me, and as you saw, I'm clearly terrible at it. So shaders is not something that I've investigated too much, but I would like to investigate it at some point. Wow, Israel, Serbia. This is amazing. So much nicer with clean screen and without timer. Well, that's nice of you guys to say. I'm glad you enjoyed this with the timer. Somebody must be watching this in the middle of the night based on all these time zones that you guys are at. Is it light out in Finland right now, though, even if it's the middle of the night? That must be nice that it's spring/summer there. Okay, thank you, everybody. Stay in touch. Let's think about a way to ask questions or chat as a community. Maybe Slack was suggested, subreddit was suggested. I would love to have like upvoting for like challenge ideas, that type of thing. So help me figure that kind of stuff out. And I'll see you guys hopefully next week sometime if you're going to keep tuning into this. Appreciate it, all right? Enjoy your weekend. Enjoy your rainbows. Go outside. Get away from your code. And talk to you all soon. All right. And I'm still streaming. I just hit stop on the record button. And now I'm going to